Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Doper Jr., the math tutor and an instructor of mathematics at the University of Liberia. In my today's lecture, I will be looking at differential equations, and particularly I'll be looking at solving first order differential equations by means of variable separable. So we want to solve more problems under variable separable. It's a kind of method that is used to solve a differential equation, but it is used whenever you notice that you can separate the expressions, all of the expressions in x on one side of the equation and all of the expressions in y on the other side of the equation. When that is done, or when that is possible, then it means that you can apply variable separable by integrating both sides of the equation to find your general solution. So let's solve the if problem. We in the previous lessons we solved like 7 other problems. So we want to solve the if problem now on this topic. So so we look at the two terms here. So the first term here you have 3e raised to the power x tangent of y dx. Now in this parenthesis you have all in x times secant square y dy. Now, so what we need to do is to ensure that all of the terms that has x must be attached with the dx on one side of the equation, and all of the terms or all of the expressions with y must be attached with dy on one side of the equation. So because this is dy, so I maintain dy on the left hand side of the equation. It's for no other reason. It's just because I want to think of how I can solve for the y at the end of the day. So I want y to be on the left hand side. Equals, now I send this term across, it becomes negative 3 e raised to the power x tangent of y dx. So now I can divide both sides by, for this side I need to get rid of all expression with x. So 1 minus e raised to the power x is an expression in x. So I divide it on both sides. 1 minus e raised to the power x. This one, only x expressions must be on this side. So tangent of y must leave. So tangent of y left that portion. So you have this carrying this out, and then this one carrying this one out. So we have now secant square y dy all over tangent of y equals to minus 3 e raised to the power x dx all over 1 minus e raised to the power x. So because now the variables have been separated, all x and all y, or let's say all x and all y, we can now integrate both sides to get the general solution. So for this, we can apply the u substitution. So we say let u equals to tangent of y, such that if we differentiate tangent of y, we get secant square y. So the u now equals to secant square y dy. And then on this side, we can say let v equals to 1 minus e raised to the power x. And why are we doing that? We notice that if this 3 comes at the back of this integral, you're going to have like negative e raised to the power x. So if you allow your u to be this denominator, the derivative of 1 is 0. The derivative of negative e raised to the power x is negative e raised to the power x. So you will have negative e raised to the power x dx in it on the top. So now we can have v equals to this. We differentiate v, the v now equals to negative e raised to the power x dx. So that's the numerator expression. So we can plug it in. We have the integral of this numerator is du, the denominator is u, equals 3. The integral of, now the numerator now is dv, the denominator now is v. So if we integrate, the first one is the ln of u equals 3 the ln of v plus some arbitrary constant c. So if we just bring everything on one side of the equation, we can have the ln of of u minus the ln of v raised to the third power, because this power can go across. It can go, this 3 can go to the power of this function. Minus, now this c, we can just make it to be ln of c. Remember I told you it means nothing, it means no change to the problem because it is still a constant. So the reason why we attached ln to this c, because we want like everything to be the same so that we can bring in the property of logarithm. So the ln of a minus the ln of b is equal to the ln of a, which is now u all over v cubed, minus the ln of c equals to 0. So now there's the ln of a, now there's the ln of b. So the ln of a minus b minus the ln of b is just equals to the ln of a, right, divided c or b, because a and b. So it's just this divided by this. So if you reciprocate now, you get kind of multiplication. So we're just going to be like, it's just going to be the ln of u all over c v cubed equals to 0. So what is our u and v? But before doing that, we can solve. Yeah, let's solve for this u. Let's get rid of this ln. We know that if we take e on both sides of the equation, e raised to the ln of an expression is just equal to that expression. So this whole thing here is just equal to u all over c times v cubed equals e raised to the power 0. What is it equal to? It's just equal to 1. So if we cross multiply now, remember we can get we can be able to get how do you call it, u. So if we solve for u now, we just have u to be equals to c v cubed. But what is our u? Our u is equal to tangent of y. So u is tangent of y. C, what is our v? Our v is equal to 1 minus e raised to the power x all cubed. So this is the general solution of the differential equation. So this is how we find the general solution of a differential equation using variable separable, right? So thanks ever so much for watching. See you in our next video. Thank you.